The purpose of this video is to introduce the heat exchanger experiment. This is the heat exchanger experiment. So the idea is to be able to test the performance of 3 different heat exchangers. First of all, I just wanted to mention that people tend to think that this actual tan box unit is the heat exchanger. That is incorrect. The heat exchangers are actually attached to the front-facing panel of this box. This right here is a miniaturized version of a shell and tube heat exchanger. This is a double pipe heat exchanger, and then in the middle here, attached to the front face, is a plate heat exchanger. So there are 3 different heat exchangers. This unit is actually controls the temperature and flow rate of the hot water. And then for the cold water comes directly from the tap from this valve here and then flows into the unit. The only thing you can do with the cold water is control the flow rate. This unit here controls again the hot water. So here there's 4 different tubes or tubes coming out of here. We have the hot water coming out of the unit going into the heat exchanger. We have the hot water returning out of the unit back into, out of the heat exchanger back into the hot water unit. Cold water out into the heat exchanger, and then cold water out of the heat exchanger back into the unit. All these attach with what I think is called quick connects. They attach and release pretty quickly. So right now I'm going to go ahead and I'm going to detach each nozzle. Now the cold water can be a little bit tough to detach, so just hold it down and work it ever so gently. Do not be rough with this machine, as it could easily spring a leak if you yank and pull too hard on the connections. Everything should release pretty effortlessly. And another thing is when you're trying to move this around to attach it to other heat exchangers, make sure the tubes are not pinched. You can actually turn them on the attachment here. You can turn it in order to allow the pipe to allow the tube to be able to be moved a little bit easier. The other thing is that you can arrange each heat exchanger to be parallel or counterflow. Now, parallel flow is done in such a way that the hot water and the cold water going in to the heat exchangers on the same side. That would be parallel flow. And if you have the hot water coming in on a different side of the heat exchanger than the cold water, then that would be counterflow. So, for example, I have hot coming out of this machine into the double pipe heat exchanger there. So I'll put the return. I'll have to twist this a little bit in order to be able to move this up in such a way that it doesn't get pinched. You can see it's kind of pinched right here, so all I would do is come back down here and twist this so that this is no longer pinched. Although I think it's still going to be pinched ever so slightly. So I have to remove this and just turn this even more so that is no longer strained. Okay, so now I have hot coming out of the hot water unit into the heat exchanger on this side. I want to set this up for parallel flow. So I'm going to do the same thing for cold out. Cold out, I'm going to attach. Might need to press in a little bit. Like I said, the cold water can be a little tricky to get in. I'm going to press in on the button here in order to be able to push in the attachment, so everything's lined up pretty well. Now it's set up for parallel flow. Now I'm going to go ahead and turn on the flow. So here is the cold water. Again, all I do is flip up the knob and you should hear the cold water flowing. You can come down here and you can see the flow rate scale. The flow rate's measured by this floater. You look at the top portion of where the floater is, and that will give you what the flow rate is. So right now it's in grams per second is the unit, so right now it's about 32 grams per second. And as you turn the knob, you can control the flow rate for a maximum flow rate of about 50. So I'm going to set this to about 30. Now, here you have two switches. You have the main switch, which turns on the hot water flowing, and then here the heater switch, which turns on the hot water heater. And again, you can control the hot water flow rate here. I'm going to set it to about 30. Alright, so there's a few numbers here. First off, this right here is what's called the set point. That is the temperature that I want the hot water to be at when it is coming out of the hot water unit. As you can tell, and this is the actual temperature of the hot water as it's coming out of the hot water heater, which is inside this unit. So since I just turned it on, you're going to see that this is going to be very transient. You're going to see this number changing, the green number, which represents the temperature of the hot water coming out of the hot water heater. So what's going to happen is that this is a controlled by a PID controller, and the heater is turning on and off and regulating itself, regulating the water temperature by turning on and off. So you're going to see this temperature rise probably above 50, so you're going to see it increase in temperature. It'll probably go to 52, then down to 49, then up to 51, and eventually level off. When you first turn on the unit, it could take it up to about 7 minutes to level off. But once the unit is leveled, it should anytime you make a change, whether it's to flow rate or to configuration, it should only take a few minutes to regulate. This temperature is set to, you have here a knob where you can switch the temperature, T1. The only concern, there's 12 actual numbers on this temperature unit selector. I can't quite focus in on it too well. There we go. You might not see it, but the number 12 is right here. You're only concerned with the first 4 temperatures. So I'm going to turn this to T1. T1 represents the temperature coming out of the hot water unit. You might ask, what's different between the temperature measured here, indicated here, and the temperature indicated here? This is the temperature coming out of the hot water heater inside the unit. This is the temperature of the hot water exiting the unit. And there's probably about a foot to 2 feet worth of tubing between the exit of the hot water heater and the exit of the unit. This is the temperature you're actually concerned with for your measurements. T1, you can see is measured here, is indicated here, T1, that is the temperature coming out of this unit, which is basically the temperature into the heat exchanger, the hot water in. T2, which there should be a number 2 here, you can't quite see it because I think it actually fell off, but T2 is basically coming back into the hot water unit, which is coming out of the heat exchanger. So here's T1 is hot water into the heat exchanger. If I switch it to T2, that's the hot water out of the heat exchanger. T3, which represents cold out of the unit. So basically it's cold water coming out of this unit into the heat exchanger. So it's basically the temperature of the cold water into the heat exchanger, T3, and then T4 will be the temperature of the cold water coming out of the heat exchanger. Okay, and then when you want to change configurations, you need to go ahead and turn off the hot water, the heater switch, turn off the main switch of the hot water, and then what I would do is change the hot water configuration. So right now it's set up to parallel flow. If you want to set it to counter flow, you would just unattach the hot water tubes or pipes or the quick connects, plug it back in, and then turn the unit back on. When you actually want to switch configurations, you don't really have to, but I would turn off the cold water flow just by turning that switch off and then turning everything off and then switching to a different heat exchanger. And you have 3 heat exchangers to analyze: parallel pipe, plate heat exchanger, and shell and tube. When you're totally done with the experiment, make sure everything's off, including the cold water flow. This concludes the video for the heat exchanger experiment.